Hello, everyone. I'm Karthik Daral. I'm a senior product manager on Amazon Monitron. Today, I'm here to share with you how you can quickly enable predictive maintenance for your industrial equipment using Amazon Monitron, an end-to-end system. Imagine an industrial site, be it a manufacturing plant or a fulfillment warehouse. Typically, such a site has hundreds of equipment that drive complex processes. When such an equipment fails unexpectedly, it is a nightmare. You to firefight and fix it on priority. At the same time, you incur significant cost from lost productivity. And this is a common and costly affair in the industrial world. 82% of the industrial companies have experienced some sort of sudden breakdowns in the past 3 years, experiencing anywhere between 5 and 20% reduction of productive capacity, an annual cost of $50 billion. To counter this, there's a growing shift to predictive maintenance strategy. Let us look at this chart that shows the equipment uptime in relation to time to detecting failure. As you see, the earlier you detect failures, the higher the equipment uptime. Now let us overlay the different maintenance strategies on top of this chart. Quite a few customers adopt a reactive maintenance strategy. In this strategy, you fix an equipment when it breaks down. Because you have to stop your processes in order to fix the equipment, you lose crucial operating hours during the fixing process. This means a reactive strategy is typically associated with a low equipment uptime. To offset this, customers adopt a planned or a preventative maintenance strategy. In this strategy, customers schedule maintenance activities periodically, for example, every 3 months or every 6 months. The benefit of scheduling periodic activities is you can catch failures during these maintenance activities. However, there are downsides. Failures can still happen outside of these scheduled planned maintenance activities, which you may not be able to catch. At the same time, because you are performing maintenance based on time and not based on the actual condition of the equipment, you may end up over maintaining your machine, which may also not be good. To address these challenges, few customers have started adopting a predictive maintenance strategy. In this strategy, you only schedule maintenance depending on the need, and this is done by tracking the condition of the equipment. Predictive maintenance has multiple components. At the very foundation of it is anomaly detection. Here, you track the condition of the equipment you're monitoring and detect anomalies in this condition to take actions based on them. Next is diagnostics. Here, you detect the root cause that is a precursor indicator of a failure. This could either be lack of lubrication or misalignment that could result in an impending failure. Third, you can also do predictions. You can estimate the remaining useful life of the equipment. This has two benefits. One, it allows you to stretch the operating life of that specific equipment till its very end. Second, it allows you to schedule maintenance at a time that's suitable to you. And finally, closing it all out, as part of the predictive maintenance strategy, you schedule a maintenance at a specific point in time ahead of its impending failure. Data indicates that 80% of maintenance activities are based on time today. However, only 11% of the failures that happen with industrial equipment are related to age. This clearly signifies a need for adopting a predictive maintenance strategy. The good news here is technology has been evolving. We now have affordable IoT and AI technologies that can detect changes in a condition and enable predictive maintenance. That said, predictive maintenance solutions are not easy to implement. Imagine you had to monitor an equipment at your industrial site. You would have to start by retrofitting sensors to this equipment. If you look at sensors out in the market, most of them are quite expensive, and they require you to invest in complex cablings. After you retrofit these sensors, you'll have to hire a hardware engineer to write code on the microcontroller and connect that sensor to the IoT core. You'll also have to do this in a secure way in an age of increasing connectivity. Collecting and storing data is just the beginning of the puzzle. The core piece is to interpret the data so that you can take actions based on it. In order to interpret the data for anomalies and to do it accurately, you may have to apply sophisticated techniques, including machine learning. To do this, you'll have to invest in machine learning or data science talent. Finally, it's not just you have to detect these issues, but you have to inform your end users of these issues. End users in this case being technicians and reliability managers that are going to maintain these machines. You'll have to equip these technicians with capabilities to track these issues, to look at historical data, and to take actions based on them. All these steps mean that it takes months, if not a year, to even do pilot in predictive maintenance. And it incurs hundreds of thousands of dollars of cost, depending on the scale. This practically puts predictive maintenance out of the reach of most industrial customers. To address these challenges, we built Amazon Monitron, an end-to-end system for equipment monitoring. By making it easy, quick, and cost-effective, we are reimagining how we can enable predictive maintenance for industrial equipment. Amazon Monitron is an out-of-the-box system to enable predictive maintenance. It includes everything you need to get started with predictive maintenance. It comes with Monitron sensors. The sensors, they capture the vibration and temperature data of the equipment. This data is then transferred over to a local gateway, which forwards the data to the Monitron service. In the service, we analyze the sensor data using a combination of vibration ISO standards and machine learning. These insights are then delivered over to the Monitron app, which is used for two purposes precisely. One, in the first place, configure and provision these devices, that is the sensors and the gateways. And second, to consume the insights coming from the Monitron service and to take actions based on these insights. Monitron can be used to monitor a variety of rotating equipment. These include motors, gearboxes, pumps, bearings, compressors, and fans. These rotating equipment, they are critical components of most complex processes. Vibration and temperature are key leading indicators of the health of these rotating equipment. By allowing you to monitor, which is a combination of to measure and analyze the vibration and temperature data coming from this equipment, we are equipping you to enable predictive maintenance for this rotating equipment. Let us look at a few key features of Amazon Monitron. First, it comes with fully managed, low-cost wireless sensors and gateways. The sensors are wireless, which means you don't have to invest in complex cabling to get them up and running. Both the sensors and the gateways are fully managed. They are pre-configured to run with the Monitron service. This means you do not have to write a single line of code in order to get started with Monitron. Monitron comes pre-built with machine learning and ISO standards-based analytics. We've taken years of experience of maintaining machines in our fulfillment centers and put that knowledge into Amazon Monitron. With Monitron, you get out-of-the-box experience for these analytics. Monitron delivers timely notifications in the Monitron mobile application. Using these notifications, technicians and reliability managers can take actions and fix those issues that come from those machines. Finally, Monitron has support for adding machine learning feedback within the app. With just a few taps in the app, technicians can add feedback on the alerts they received. They can give a thumbs up if the alert was useful or a thumbs down if the alert wasn't. Monitron uses this feedback to continuously train the underlying machine learning model to improve the ongoing performance of these alerts. Let us look at some of the benefits of Amazon Monitron. First and foremost, Monitron is built to help you reduce unplanned downtime for your industrial equipment. By delivering early insights into the condition of the equipment, Monitron equips you to fix it before it fails and helps you reduce costly cost associated with unplanned downtime. Second, Monitron is quick to install and no special skills are needed to use it whatsoever. Using the Monitron app, you can provision the Monitron sensors and gateways in a matter of minutes. No knowledge of machine learning or technical expertise is required to set up and use Monitron. Third, Monitron has low setup costs. You have a very small upfront device cost associated with Monitron, which is a fraction of the cost of using expensive conventional sensors. Monitron service fee is pay as you go. So you only pay for the amount of time you use the service. There are no licensing fees or long-term commitments. Monitron is also end-to-end secure. That Monitron provides end-to-end encryption of the data at rest and in transit. The device, the service, and the communication between them is fully secure. Last but not the least, Monitron offers continuous improvements. This is on two fronts, one on the device front and one on the machine learning side. On the device front, both the sensors and the gateways can be remotely upgraded with newer software using over-the-air upgrades. What this means is if we come up with improved software for these devices, we can push this onto the devices in the field and the devices can benefit from improving capabilities. As an example, we recently increased the battery life of our sensors from 3 to 5 years by running optimizations on the software. The devices in the field were also able to benefit from this increase in battery life due to the over-the-air upgrades. Similar to the devices on the machine learning side as well, Monitron offers continuous improvements. Monitron uses the user feedback that is provided within the app to continuously retrain the underlying machine learning models. With this, Monitron delivers improving alert notifications so that end users can use these alerts in an improving fashion. Now that we have seen an overview of Monitron, let us look at a short demo to see how you can set up and use Monitron.
Let's say you are a food and beverage company and you decide to monitor a pump at your Dallas site. To get started, you order the Amazon Monitron sensors and gateways on Amazon.com. Let's assume you received these devices. Next, you want to set them up in order to monitor your equipment. You go to the AWS console and search for Amazon Monitron and launch the service. You start by creating a project. A project is where you register sites and assets that you want to monitor. You enter a name for your project. Typically, you want to enter your company name here. Let's say company XYZ. Next, you want to add an administrator to this project. This could be the reliability manager at your Dallas site. Let's call her Jane Doe. You can create Jane as a user. Next, you add Jane to the project. As you saw, the project was successfully created and Jane was added as a user. Next, you invite Jane to access this project by sending her email instructions. Let's say you already did that. Once you do this, Jane can use the Monitron app to start monitoring the pump. Let's go into the app to see how she would do that. Let's assume that following the instructions in the invitation email, Jane installs the Monitron Android app and logs into it. Once inside the app, Jane can set up the Monitron sensors and gateways and start monitoring the pump. She starts off by installing a gateway. To do so, she navigates to the menu and to the gateway section and adds a gateway. While doing so, she makes sure that the Bluetooth of her phone is turned on and she presses a commissioning button on the side of the gateway. The app looks for available gateways in the vicinity. Jane selects the gateway. Now the app looks for available Wi-Fi networks at the site. Jane selects a suitable and secure wireless network at the Dallas site and onboards the gateway on that site. The installation process of the gateway is very similar to how you would install a smart home assistant such as an Echo device at home. The function of the gateway is to automatically and securely transfer the sensor data to the cloud. It does so by communicating with the sensor over Bluetooth Low Energy and with the cloud using Wi-Fi internet. A few moments later, the gateway is connected to the Monitron service in the cloud. Now that the gateway is connected, Jane can register the pump and pair sensors to it. To do so, she goes to the asset page. Here, she adds a new asset. She calls this asset pump and identifies the ISO 2816 class of the asset. Now that the asset has been added, Jane can pair sensors to one or more positions on this asset. To do so, she clicks Pair Sensor and identifies a name for the position. Let's say she wants to pair the sensor to the motor of the pump. Next, Jane brings the smartphone close to the sensor. Amazon Monitron uses near-field communication technology to seamlessly register the sensor in the cloud. In a few seconds, the sensor is paired to the position and goes online. Jane can now physically mount this sensor to the motor of the pump using the suggested adhesive. Once done, the sensor starts capturing vibration and temperature data, and Monitron will start monitoring the pump. The first set of data on temperature and vibration already trickled in. As you saw, all these steps were simple and quick, and Jane was able to start monitoring her equipment in minutes. Jane did not have to write even a single line of code to start monitoring the pump. Once the sensor is installed, Amazon Monitron trains a machine learning model by baselining the vibration and temperature patterns of the equipment. It sends an alert when it detects an anomaly based on this model. These alerts are sent as push notifications and can be viewed in the bell on the top right corner. As you see, 3 alerts were received in the month of November. When an alert is received, Jane can conduct physical investigations of the equipment and fix the issue. In doing so, Jane can either click on the alert or navigate to the position under consideration to look for historical sensor measurements and draw insights. Once the issue is fixed, Jane can resolve the issue in the Monitron app by clicking on the Resolve button. Jane can also provide feedback at the same time by providing the closure codes, which are failure mode, failure cause, and the actions taken. If no issue was found in the equipment, Jane can also indicate that in the app. When Jane does that, Monitron treats it as a false alarm label for the machine learning model and retrains the model based on that. As you see, Jane was able to leverage the power of machine learning and monitor the pump. She required no machine learning knowledge or expertise and did not have to do any development work in doing so. Through this demo, we saw how you can set up and use Amazon Monitron to monitor your equipment.
Against this backdrop of demo, let us look at how the end-to-end system works. As you see, Monitron has 3 distinct components. There are the devices, the Monitron service, and the Monitron app. The devices are essentially installed on the premise or the site where your machines are. You install these devices on the equipment, say for example, a motor or a gearbox or a pump, by by using industrial additives. The sensors, once provisioned, communicates with the gateway over Bluetooth Low Energy, and then the gateway communicates to the AWS cloud using wireless network. In the cloud, as we discussed, we run our analytics, which is a combination of vibration ISO standards and machine learning based analytics. And finally, the app is used for consuming the insights coming from this analytics. The app is also used to provision the devices in the first place. Let us look a bit more into the monitoring experience that Monitron provides. As you know, the core value prop of Monitron is equipment monitoring. We enable this monitoring using a combination of machine learning and vibration ISO standards-based analysis. Monitron essentially learns over a period of first 2 to 7 days and baselines a model during this learning period. Once learned, Monitron starts inferencing the incoming streams of vibration and temperature data and looks for anomalies in them. However, it does not raise an alert for one-off anomalies, but instead it looks for persistent anomalies. The reason here is the application that Monitron is helping address is this application of condition monitoring and predictive maintenance. We see that anomalies that can persist indicate persisting conditions that are indicators of failure. And so by only alerting on these persistent anomalies, we are giving true indicators that require investigation and fixing. Based on the user feedback collected, Monitron retrains the model that was built during the learning period. This is an ongoing improvement that happens, and every time user feedback is received, the model is retrained. Monitron also classifies the alerts into different severities, specifically two, a warning and an alarm. End users, i.e. the reliability managers and technicians, can use these severities to suitably prioritize the right alerts to investigate. Alongside raising alerts, Monitron also explains the reasons behind alerting. The way it does it is through a commentary section that is in the app. For example, if an alert was raised because of vibration, Monitron would call it out that the alert was driven by vibration. In another instance, possibly the alert could be raised by temperature, and Monitron would call out that this was because of the temperature. Also, Monitron explains whether the alerts were raised by the machine learning model or because of the ISO standards-based analysis. By providing this visibility, Monitron is assisting end users, technicians, to get a better handle on the alerts and help them in investigating the issues and fix it. Now let us look at how customers have been using Monitron. Multiple customers have used it and found it quite useful. For example, Amazon is using Monitron to monitor conveyor systems in the fulfillment warehouses. Let us look at a short video of how Amazon is using that.
The volume plan for this building is really close tied to the max machine capacity we can run through the systems. So meaning every downtime of at least half an hour or 50 minutes will cause a lot of packages which are somehow piling up somewhere in the building.
So Amazon Monitron will be used mainly on the conveyance. We have 26 kilometers of conveyance in this building, and that's got to be running at all time in every corner of the building.
At the moment, around 1,000 of these sensors are just located all over the conveyance system in our building. And the first couple of days it's learning. So it's learning how the system is running, what is the normal temperature of a motor, what is the normal vibration of it. And every deviation is directly alerted via our warehouse management system to our ME technicians. And they can just go there and have a look.
We have an indicator and sensor give us the signal. We have an defect motor, so we saw the temperature was very high. The team make the decision to exchange the motor before we have an outage, and we can work together with operations that we set up a maintenance window in the right time and to make sure that we have no impact on the customer.
Over the next 12 months, Amazon fulfillment centers will deploy tens of thousands of Monitron sensors across dozens of sites worldwide. This will help them reduce unplanned equipment downtime and improve the customer experience in terms of package delivery. Externally, multiple customers have used Monitron. For example, GE Gas Power used Monitron to monitor the health of tumblers at their turbine plant in Maine. Tumblers are these equipment that are used to polish the airfoils that go into the turbines. These tumblers in themselves have a variety of rotating equipment, from bearings, shaft, to gearboxes. Previously, GE Gas Power had been meaning to monitor this equipment, but because of the cost and the complexity of building a technology solution, they had deprioritized it. With Monitron, GE Gas Power was able to retrofit these tumblers with sensors and connect them to real-time analytics in the AWS cloud in a matter of 10 minutes. It was extremely easy to use for the operators. They did not require any technical skills or knowledge of how to configure their IT and OT networks. Fender, a guitar manufacturer, has used Monitron to monitor the blowers that basically keep their paint shops dust-free. Fender found the Monitron product extremely easy and cost-effective to use. Based on their experience, they feel that Monitron is not just useful for the large industrial customers, but also for small mom and pop shops because of the ease of use and the cost-effective nature. RS Components is a leading electrical and maintenance component distributor. It distributes over 500,000 products from over 2,500 suppliers. RS is excited to partner with AWS and Monitron to offer first of its kind end-to-end wireless vibration and temperature condition monitoring solution in its portfolio. As you've seen over the last few slides, Monitron is very easy to use, and it can help you quickly get started and enable predictive maintenance for industrial equipment. You can also get started with it in an easy way. Here is how. You can go on to Amazon.com or Amazon Business and purchase the Amazon Monitron sensors and gateways. The sensors and the gateways are available in 3 different SKUs. You can buy a pack of 5 sensors, or you can buy a gateway, or you can buy a starter kit, which is a pack of 5 sensors and 1 gateway. These sensors and gateways are available on Amazon.com in the US and also on the European marketplaces, namely France, Italy, Spain, Germany, and UK. Once these sensors and gateways are received, you can use the Monitron app to set up these devices and physically install them on your machines. And once you do that, you can monitor and start managing your equipment. As you've seen in the previous examples, it's extremely easy, quick, and cost-effective. And you can quickly enable predictive maintenance for industrial equipment. Thank you. Questions?